In this video, we are going to talk about the Typescript Generics. Typescript Generics is a feature from the Typescript which allows you to derive the types at a runtime or when a particular that type or the generics has been used as a type somewhere in the code. So it is used to derive a type depending on where and how it is used. So that is the fundamental definition. Most of you will be aware and be using it, but there are some really awesome and the cool things that you do with the TypeScript generics. In this video, I'm going to talk about some advanced level stuff that you can do with the generics which will enhance the code quality. So I'm going to take you through some cool examples and let's dive in. Before we start, humble request to subscribe to my channel. My channel is a really small scale channel. I don't get any financial benefit. Stat shows that around 97.6% of the people who have watched my video have not subscribed to my channel yet. So please subscribe to my channel. It's completely free for you. It doesn't give any financial benefits to me, but seeing that support and encouragement from you guys, it motivates me and I keep on doing the similar content in the future. So please do subscribe. So I have a very simple example here. So this is what we have been doing with the TypeScript generics. If I have interface, let's call a pair, then I have a T and U as a generic types, which are argument to my interface here, interface pair, and then I can use them as a type in my properties here inside interface. So first can be T, second can be U, and then I can use it in my object here as a pair equals to pair of number and string, and I can like do whatever here. I can pass any value that I want. For example, I can say string and maybe a string again here or something different. Let's call it object. Then I can do is I can use the different values and see if I'm not using the specified value. It is saying that the number is not assignable to a type of a string. This is the basic use case that what TypeScript generics feature provides at its core. In this video, I want to take the things to a next level. I want to show you that there are some advanced level of stuff that you can do with the TypeScript generics, and it is really easy to understand. First one is the conditional type. So you can use the TypeScript generics to make a conditional types. So this is a really simple example what I got here. Type is number and I have passed a T as there, and the T extends number, then I'm saying that it is going to be true or false. So usually the conditional types are used with the extend keywords, and depending on it you can check for the characteristics of a particular variables type. For example, in this case, if T extends a number, then we are saying that the type has to be true. If it is not, then it has to be false. And then you can use it for your use case. For example, I have here example 2 is number 100. If I pass 100 to here, then it is going to return a true. If it is something different, regular expression, let's say, which is not defined here, it's going to return a false. So you can derive the types of your variable conditionally using the TypeScript generics along with the extend keywords in this manner. And conditional types can be nested. It can be created using a type that is depends on another conditional type. Now I know this is a little complicated to read and I might be sounding stupid to you guys that what the heck I have wrote here. But the point what I'm trying to convey here is you can use the conditional types in a nested manner. Like I have the extends on the outer level here, and inside that I also have another extend. So what I'm doing is I'm conditionally deriving the some types, and depending on the condition, I'm saying whether it can be a number or the boolean or it can be a string. So that's all happening in this example. And that is the characteristics of the TypeScript types, that they are static. That means the types are derived at a static time, so you don't have to wait at a runtime. That's where my third example come, where I would show you that how you can use the TypeScript type to get the return type of a function. So let's say I want to get a return type of any function. I'm gonna have any function, any valid legit TypeScript function. I'm gonna pass that as an argument to my return type, and what it would give me is the return type of that function as a type. So let's say I have a function called addition. It returns a number. Then if I pass addition, then it would return me a number as a type. If I have a function called reverse string, pass that reverse string function to my return type, and the reverse string returns a string, then my return type function going to give me a string. So it's like a whatever function you have, whatever the return type of a function that is passed to my type, it would return a return type of that thing as a type. So for those of you who don't know what infer does, it helps you to infer the type depending on the result of the previous expression or the previous statement. So it is a whole different topic that can have a different separate video. I'll probably make that in a coming days. But for now, for the sake of the scope of this example, the infer helps you to derive the type of your left hand side expression. So what I'm saying here that the t can be a function which can have an arguments, they can be of any type, and what I want is the r which is going to be return of this function. If it is a r, then return a r, or if it is not r type, then return any. Now I can use this in an example. So this thing is going to return me a void because my function which is passed here as a parameter to my generic type is returning a void. That's why void. And in case of example 2, I'm passing the just number. This is not a valid function, by the way, because my return type is expecting a function. That's what I put here, like t should extend the function. It has to be a function. But in the case of the second example, I'm passing a number which is not a function. That's why it is going to return a any here, because that was my fallback condition here. Next thing is map type. So map type is a type that is derived from the existing types. So it uses the existing type to create a new type. There are certain keywords like a partial, peak, capitalize, which you can use along with a map types to create something custom. Of course, you can create your own map type as well. And not just that, you can also play with the keys of an object. So you can use a key of keyword to get an information about what are the keys of a certain object and create some complicated type. So let's say I have an interface called app config. Inside that I have username and the layout. So what I can do is I can write something like this app config keys, which is the key of app config, which simply means that the app config key is going to have the values which can be a username or the layout or whatever keys that you have inside the app configs. Additionally, you can also use a keywords like in and as. Thanks to them, we can access to the individual properties of any object. Then I have type async, and it is having the property in the t, and which also returns a promise of void. Now what I want to do is I want to create an async messenger. Give me the same properties that I have in the messenger, and it would put an promise of void as a return type to this. So what I can do to achieve this is create a type async t, and the property has to be a key of t. So whatever type I'm going to pass here, so the property has to be the syntax of the send file, because I'm passing a messenger here as a t. There's another keyword called capitalize that you can use to capitalize the keys of your type. So in this example, I have messenger, same example, and I have the async. What I'm doing here now is property is going to be key of t, and that property has to be capitalized of it. So property and then string, and then the return type is going to be same what we had in the previous example. So this time it is going to give me a result as send text and the send file. Notice this s has been capitalized. A third use case is a template literal types. So template literal types is a feature which is actually same as a template literal string what we have in the JavaScript. Template literal allows you to create a custom types, certain sequence of the characters and the string in it. It is more like a regular expression, and you don't have to write annoying, super difficult to understand a regular expression. So what I got here is a URL, and what I'm saying here in the template literal types that it has to start with the https colon slash slash double slash, and then it has to be string, then dot, and followed by a string. And with this I simply created a URL type. If I use it in my example URL1, this is completely fine. If I say that URL2 is URL and give just test, then I would get an error which is test is not assignable to a type https string. And you know what is a great thing about it? You can use the template literal also in your keys in a properties. That means you can also put a check on your properties that property has to follow this certain pattern. I have a type called person and the name, and the key has to be a phone and the number. Phone is a starting prefix of this property, and then it need to be followed by any number, which means that I would have a person type which have a name, and then I can have the multiple phone properties inside it, and the syntax of it is it has to be started with a phone and then followed by the number. That's something different. If I pass something different here, the TypeScript is going to complain that object letter may only specify known properties and the phone's one does not exist. This is how you can put an template literal type check on your properties as well. And one good example which I couldn't resist to mention here, which I couldn't avoid to mention here, is of the Tailwind CSS classes. Tailwind is everyone's favorite CSS library. I use it extensively for many stuff in my project. That is actually a good example of the template literal type in the TypeScript. So what I have is a base color which can be gray, red, yellow, green, or some more. Then the variant can be 50, 100, 200, 300, 400. Then I want to create a Tailwind color So for those of you who don't know what is the Tailwind color, it's like a set of the classes name that we have in the Tailwind CSS, which are usually like the red 200, red 300, red 400, 500, where the 400 or the 500, this number indicate the intensity of it. And depending on that classes name, it decides the what CSS properties to apply. So here through the template literal types, we can construct a pattern for the Tailwind classes, then a dash, single dash, and then comes a variant. So which means that my Tailwind color can be gray, dash 50, 100, 200, 300, 400. So this is how the Tailwind CSS classes are there. This is the simple pattern matching. Imagine now if I try to do with a regular expression, I would have a separate function adding the syntax of the regular expression, which is I know every developer struggle to do. It's not a thing that we can achieve in a first single go. Typescript generics and the template literal types, it has become very easy. This is not just a way more less lines of code, more cleaner and very easy to understand. The readability is super here. So that's it example in this video. I want to demonstrate how you can use the TypeScript generics to achieve some complicated stuff with a very less lines of code, make your code more readable and clean. If you like this video, a humble request to subscribe to my channel. And in the coming video, I'm going to talk about the TypeScript infer. So if you are interested in knowing what are the use cases of the infer and how it would help you to improve the overall readability of your code, then stay tuned. One more reason for you guys to subscribe to my channel. Thank you for watching this video. Bye bye.